So we're going to take a look at the GPU Surface Effects tool that we demonstrated at GDC and that's available with XSI version 3.5. I'm going to go get the scene GDC Eric Basic Walk from the database. We'll load that in, and that contains two models: a high-resolution night model with lots of mental ray shaders and effects attached, and a very low-resolution model, sort of games version with no materials or textures or anything at all, just a UV space. So we can see here we've got a nice high-resolution model. It's quite slow, it's quite heavy, and it's several hundred thousand models. In fact, if I go open this up, we'll see that has something like 263,000 triangles. And if I go and look at the low-resolution model, which we also have hidden in another layer right now, I'm just going to shrink that up. We go and get rid of the high resolution one. We'll disappear him for a second from the GL view. And we've got our low resolution model, which is much snappier in the interface, and we can see that it has about 3,900, 4,000 polygons. So that's our low resolution version. Now what we're actually going to do is we're going to use the GPU Surface Effects add-on, which comes with XSI 3.5. I'm just going to get that. It's a NetView add-on, so it's in the NetView page under the add-ons tab. We'll just go look at that, and here it is. Now this is the 3.0.1 version that we used at GDC. The final version that you'll have with 3.5 has a few more options and some more presets. It's basically two NetView pages inside the add-on. One for preparing the scene to run the effect, and two, a series of real-time shader presets to allow you to visualize the results directly in XSI if you have hardware with the latest generation GPU graphics accelerators such as NV30 or GeForce Effects or ATI 9000 series 5GL or Radeon 9000 series graphics cards. So in the version you'll probably have there's CG OpenGL presets as well, and you'll have more presets there. So what we're going to do to begin with, we're just going to make sure our model, we've already prepared our layers in this scene. I'm just going to make sure our low resolution model is also visible to mental ray, and the high resolution we don't need to see it. If we just run mental ray quickly, what we'll see is that, if we just run the render region, we'll see that there's we'll actually be looking at the high resolution model. I'm just going to switch that off for a second. There we go. And what's going to happen is it's going to render the mental ray object, even though we'll be looking at the low resolution object in GL and the high resolution mental ray object with the render region, and we just be able to compare the two. And we'll see that there's a bunch of high resolution rendering effects and high quality detail on the object that really isn't there on the low resolution model. We've really only got the simple and the sort of the main features of the model, and all the interesting surface detail, all this ribbing on the metal and these little details on the buckle and even the colouring. There's just nothing on the low resolution model at all. And what we want to be able to do is we want to bake all that information down into image maps and effects maps that we can use to drive the real-time shaders and the effects hardware on the system that we're using. In this case we'll be using DirectX, so I'm using 3.0.1, and it'll show the DirectX in a pop-up view. In v3.5 you'll see that actually in a view window, not in a pop-up window. So there we go. I'm going to now close that little window, and we'll get out of the mode and go back to our GPU Surface Effects tool. We'll make that render visible again because that's where the effects are going to run. Now, so we've already built our layers. This is what this section automates, but that's already done in this example scene. We'll select our model, our low resolution model, and we'll apply the low resolution model setup script, which gives us this dialog. And what we've got here are three paths. We've got the world normal map, the tangent normal map, and the surface map, the image map. The three image maps that are going to be generated. So I just checked they're alright, that's fine. The map generation options. This is basically because underneath the hood this tool aggregates three different render map processes, and we need to output each of the images. We also need to decide on the resolution. We're going to set that to 1024 so we get a nice high quality result, and we're going to back the camera off 0.4 from the surface, because we've got a lot of sort of little details here, and we want to make sure the camera is far enough away from the surface that we don't get any interpenetration. We want to also make sure that it's not too far away to get actually get opaque pixels and black dots in the final result. Now what we can also do here is we've got several buttons that allow us to either generate just the image map, just the normal map, or all of the maps at once, which is what we're going to go ahead and do here. So I'll just hit all. Now what this is basically now doing is it's going to fire up the script. It'll generate a new pass and put a load of overrides on the high-res model and all the models in the high-resolution layer to allow it to extract and generate a map of the surface detail, all the complex and rich detail on the surface. That could be displacement, could be anything you can generate with mental array. And then after that it's going to create another pass and do that for the image map, and then finally it's going to generate some color at vertex tangents and use those color at vertex tangents in the low-res model, store them as color at vertices, the vertex tangents for the low-res model, and use that to convert the world normals into tangent normals, which we can use with the graphics hardware. So off that's going to go, and we'll let the render map do its thing. And so there we go. That was rendered all the maps now, and what you can see is there's actually a color at vertex cluster being created on our mesh. We're not using this directly. This is actually used to create the tangent normal map from the world normals, which the shader is going to use later on to actually draw to preview the result inside the view. So what we'll do now is we don't need this anymore. We're all done with that. I'm going to go back and open up the GPU Surface Effects add-on again, and this time we'll go to the material presets page where we've got our materials. Now I'm going to also open up a render tree, and what we'll see is that we've got two materials, a cloth material and a metal material. Now the cloth material is one where we don't want to have any reflection or any kind of metallic effect, so we're just going to use a diffuse bump map pixel shader, and we'll drop that on there. We'll just quick do a little refresh. You can see we've got a bunch of shaders here and one DX draw. So we're doing one pass, and I'm going to open that up. We just want to make sure that we've got the right image maps, because the preset may not necessarily contain the paths you want. So we'll open that up to the images that you've generated, and we can see that it's found the bump map, the normal map. So that's the tangent space normal map, characteristic with the cyan and blue and red colors, because what is actually in the image map is the R, G and B values of the image map represent the three axes of the normal vector for every pixel of the original model. Now I'll go to the other texture image, and that's actually the wrong image, so we'll go and correct the path to be our surface map that we generated. So it's obviously got another path in the preset, so you just need to make sure to go and do that. I'll go back to the texture too, yeah, and I want to make sure we've got the right texture space as well, so we take that there. So that's the cloth material done. Now for the metal material we're going to use a slightly more complex preset. This one, in addition to being diffuse bump, is also giving a specular lighting and bump reflection. So in fact, yeah, you can see it's a little bit more complex. I'll just make that a bit bigger, and you can see we're also using two passes. So the first pass is very similar to the diffuse bump shader, with the addition that it's actually doing a specular as well. And then we're on top of that, we're doing a bump reflection pass as well. So I'm just going to double click on that and open up that result. That shader tree. Off it comes up. We don't need this anymore. And we're going to go and check the textures here as well. So we'll just click on this one, and it's found it. We can give it the right UV domain. Next one, didn't find it, so we can pull down and go and get our surface map image, which is somewhere about, I think that's here. Let's check that's okay. And there we go, we got our surface map, we got that set. Go on through, find another texture. It's a normal map again, and this one is, I think, the reflection map that we're going to show. So we want to make sure we have the same reflection that we were using on our mental array model. So there we go. just pop that back up. That's already. And that one. So just quickly while we're here, we can have a look. This is actually the vertex shader that's running. So this is a DirectX vertex shader. We're using DxDraw, and because I'm using 301 for this example to run through this, we'll see the DirectX when we go into real-time shader mode, and then shortly we'll see the DirectX window pop up. In 3.5 you'll see that actually inside a view. And there's also some pixel shaders. I'll just show you one example of the pixel shaders. So here's another pixel shader that's doing diffuse and specular. So okay, we'll close that up. And now what we're going to do is just go and open the real-time shaders view. Takes a little while to initialize and send the textures to the DirectX surface, but there we go. So I'm going to frame that, make this a little bit bigger so we can see it more easily. And there you can see very high quality result where almost all the significant high surface detail in the original high resolution object you can see is reproduced by making use of the hardware real-time shaders. All those little details that we had that were so nice in the main object, the ribbing and so on the surface there, that just isn't present in the geometry of the mesh, is being reproduced using real-time shaders and normal maps. And in fact I think we can pop this up and I can just show you some of the lighting in a slightly better way. I'll just get rid of the spare lights that we use for the mental array part of the stage of the process, and we should have some lights somewhere in this scene. I don't know where it is exactly. I'll just zoom out a little bit, find if it's somewhere. We could probably just move that around and actually see the lighting update in the scene as we move the light around, and you can see that those normals and the specular reflections and the highlights and the bump reflection are all using and all driven by the real-time shader. So we're getting this really high quality result. So finally I think we have some animation on our little character, so I'm going to do that, and there you can see him actually walking around. And if I pop this up to full screen, we'll run a little bit faster hopefully. And there we go. Obviously there's nothing really meaningful in the OpenGL view here because we're using only DirectX shaders, so we only really see a good result in the DirectX view.